In this lesson on exponents, we're going to look at the product of powers property. The rule says that a to the m times a to the n is equal to a to the m plus n. Well, let's look at that a little more deeply. So let's start with something that we might have a familiarity with. If we have 2 times 2, we know we can write that as 2 squared. If we have 2 times 2 times 2, we can write that as 2 to the third power. If we have a whole bunch of 2's, all multiplied by each other. Let's say, for instance, I took a second and associated the first 3 and the second 4. The first 3 could be rewritten as 2 to the third power, and the second set could be rewritten as 2 to the fourth power. Ultimately, we know that this original sum product could be written as 2 to the 7th power, because we have the product of 7 2's, 2 multiplied by itself 7 times. Well, we can shortcut that by noticing that the exponents here, 3 and 4, add up to that same total. It totally makes sense if you think about there were 7 2's, and this is representing 3 of the 2's and 4 more of the 2's. So this kind of confirms our rule that a to the m times a to the n is equal to a to the m plus n. We can also apply this same rule to variables. So if I have x to the 4th power times x to the 8th power, that would be the same as x to the 12th power. Let's look at a few examples. Here we have x to the 5th times x to the 2nd. Again, we use our rule that this is now going to be x to the 5 plus 2 as our power, so this would ultimately be written as x to the 7th power. In this example, we happen to have a negative exponent. We'll talk more about them later, but for right now, we can still apply the same property. Negative 3 plus 7 is equal to x to the 4th power. In this third example, we have some coefficients here. Well, if you remember about multiplication, that we can multiply in any order because multiplication is commutative. So I'm going to choose to multiply the coefficients of each of these factors first. 3 times 7 gives us 21. And now I'm going to multiply the x's next. And I'm going to use our property that says it's going to be x to the 5 plus 11 as our power. And finally rewrite that as 21 times x to the 16th power. 21 and x to the 16th, we can't multiply that any further without knowing a value for x, so that would be our final answer. In example 4, we've got even more going on. We've got coefficients, we've got x terms, and we've got a y term in each factor here. So let's take this piece at a time. So for our coefficients, we've got negative 2 times 8, and that would give us negative 16. Remember, the coefficients are not exponents, so we're multiplying them to get negative 16. When we look at the x's, we are multiplying the x's, but their exponents don't get multiplied. Their exponents get added. 2 plus 10 is 12. That's often a point where students get confused because the coefficients got multiplied, the exponents got added. Finally, we can look at the y's here and multiply them last. Y to the 5th and y to the next negative 2nd would be y to the 3rd power. Here I just wanted to throw one additional example where we see that there are exponents on our coefficients. When that's the case, we can't multiply their bases. We don't want to multiply 3 times 3 and get 9. We have to be aware that they have exponents on them. So we're going to apply our property of exponents rule and make this 3 to the 5th power. And then we're going to move on to a's. A to the 2nd and a to the 9th will give us a to the 11th. And finally, b to the negative 3rd and b to the 4th. When we take negative 3 plus 4, we get 1, and we don't actually need to write our exponent of 1. If you do, that's fine for now, but we will push students to not write that towards the end of the chapter. When we look at this, we see 3 to the 5th. Could we evaluate 3 to the 5th? Yes, but that number is going to get exceedingly large. So assuming the number is, rather large, we're not going to go ahead and take that time to do it. So we're just going to leave it as 3 to the 5th. If we had maybe something like 2 to the 3rd, I think that is fair enough to evaluate as 8, but 3 to the 5th power is a rather large number. So we're just going to leave it as it is.